Hi, class. Um, Today we will start week 3, and we're not going to do chapter 3. We'll do chapter 3 later on, but we will do chapter 4 today. And later on, if we have a time, we will go back and do the chapter 3. So we did chapter 1, chapter 2, and we're going to do chapter 4 right now. So let me share the screen with you. I'm sorry, the resolution is not very well because there is, I'm doing some backup right now. So I'm sharing the screen with you. And this is chapter 4. And we'll be talking about strategic capacity management. I thought it's a good that you have a good understanding of supply chain management and operation before we get into calculation, deeper calculation. So we will start with the strategic capacity management, which is chapter 4. Now, the object of the learning is that we need to explain what capacity management is and why it is strategically important. We need to exemplify how how to plan a capacity. We'll bring an example of how we plan a capacity. We will evaluate the capacity alternatives using the decision tree, which is a very interesting one. So we will be talking about it more in this chapter. And we will compare capacity planning in service to capacity planning in manufacturing. So capacity management in operations means that the ability to hold, receive, store, or accommodate in business. Accommodate. In business, it's viewed as the amount of output that a system is capable of achieving over a specific period of time. So there is a limitation of times and how much the system can really have an output. In the service, it is a little bit different. So in the services, the output is often is the number of the customer served, how many customers. In manufacturing, the output may be the number of units produced or processed. So the capacity management needs to consider both resources input and the product output. So they look at the both things, how many at certain time of level, in a certain limited time, how many the resources input and product output. Now, when we do any planning, we usually have a three type. We have the long range, we have the intermediate range, and we have the short range. And the long range is usually greater than 1 year, and usually is done by the top management will do that. Intermediate range, it is monthly or quarterly plans covering the next 6 to 18 months. So every month for 18 months or every quarter for 18 months. And then you have the short range, which is less than a month. So the only thing is that the fact is that if it's 18 months and you plan every month one or every quarter one, then it's an intermediate range. But if you have one plan for 1 month, it is a short range. Now, the strategic capacity planning. Finding the overall capacity level by capital intensive resource to best support the firm long-term strategies. The capital intensive resources is made of usually the facilities, the equipment, and labor force sizes. So what kind of facilities, how many, where is located, the equipment that you have, and the labor that you need to deliver the product or the service. The capacity planning concept is a best operating level. When you talk about best operating level, the level of capacity for which a process was designed and defined as a volume of output at which the average unit cost is minimized. So the best operation level is how much you can produce as a capacity where your cost per unit is reduced. So if you took some accounting, you know, is economics, there is a certain level, there is in accounting, there is a fixed cost or overhead cost, and there is a variable cost, which is in the variable cost, the more you produce, the cost of per unit is it's a variable, it gets higher, the total cost of total unit, and the fixed cost, because it gets divided by the number of unit, it goes down. So this is where you call the best operation. The more you produce at certain level, you will be probably working more efficient, less costly. So we in factories, they use the capacity utilization rate, which is a measure of how close the firm is to its best possible operation level, which is best possible operation level when we have maximize units producing plus over current producing. So we have the current producing and the maximum unit producing. You divide them both, you divide them. And then if you have 100%, if, for example, if the factory can make 100 units, then it means that you are at 100% capacity. So you heard of the word economies of scale, which is the idea that as a plant gets larger and the volume increase, the average cost per unit, it drops. And just what we said is if you're looking at it from financial accounting or from economics, every product has two parts of it. There's a fixed cost and the economic and variable cost, or you look at it as overhead costs and unit costs in the financial. So the more you produce, the lower cost per unit goes down. But at a certain level, the cost per unit goes up, and the reason is because you start overusing the machineries, you start overusing the people, you have to pay, 1.5 rate or something like that. So once you start doing that, so the cost per unit, it goes higher, and that's what becomes the economies of this economies of cost. Now, capacity focus, the idea that a production facility works best when it's concentrated on a limited set of products or production objectives. So we have two types. We have focus factory and we have plant within a plant, or PWP. Focus factory is when a factory is focusing on producing one thing or two things, very focused productions. And that's where capacity is, the belief is pretty high. Or if you have a factory and there they can produce, there is a plant, the whole plant, you divide it into 6 or 4, and each one is like an independent working producing different products. That's also called a focus capacities. Now, capacity flexibilities, on other hand, is the ability to rapidly increase or decrease the production level. That's one thing. But also the ability to shift rapidly from one product or a service to another. So the flexibilities is how quickly you can switch from producing jeans, pants to t-shirts, something like that. But that's one way of looking at it. The second way is how quickly you can and how smoothly you can increase your production from 100 pants per hour to 1,000, for example. That's another thing. So flexibility comes from the plant itself, the factory, the process, and worker as well. Because workers they have to be multitask in order to be flexible. And it's from the strategies that use the capacity of other, or the other option that if you cannot have that flexibility, you always can utilize the capacity of other organization where you outsource some of your work or some of the process of your work. Now, so the capacity flexibility is basically there is a flexible plant, which is the ability to quickly adapt to change. The zero changeover time is the goal. So you can really easily switch with a zero changeover time, that they don't have that much. And then you have the flexibility of process, which is a flexibility manufacturing system, simple, easily set up, and set up equipment, economies of scale. So it's easy to put the equipment, attach them, and start working on them. A best example is probably when you're trying to make noodles. It's so easy to move these equipment, but if you're trying to create weeds, it's difficult because there is not much flexibility there. There is certain capacities that you have to produce, and to move more, you need more equipment, which is more expensive. So there is no much flexible setup. And then you get the flexible workers, that's a multiple skills, clustering, ability to switch from one kind of task to another kind, you would see a lot in the high-end operation like IT companies, and in probably in hospitals sometimes you can see that. So consideration into changing the capacity is you do system balance. It's a very similar capacity at each operation are desired. Manage bottleneck operation. So you do a system balance. Sometimes you have a machine that produce 100 units per hour. The next machine will take these products and make it the second step of it. And sometimes the first one makes 100 and this one makes 50. So there was lots of product, bottleneck effect there on operation. And to solve this problem, you probably need a second machine, or you need to have the first machine produce less, or you need, for example, to have the second machine produce 24 hours. Meanwhile, this operates in 12 hours a day shift probably. So the frequency of the capacity addition is when you do these, once you have an addition there is always cost involved with it. And the cost is clearly how much it costs you to bring a new machine, or how much it costs you to have more people. But there is also a hidden cost that you don't see it, is cost of upgrading too frequently, and there is a cost of upgrading too infrequently. So if you keep every time you do, upgrading, there is a cost in it. And if you know so you need to have an average, and infrequently, you're not doing enough upgrading for your stuff. So the best example, probably, if I look at it, I can tell from, for example, um, um, a hydro plant. A hydro plant, um, when the turbine machine is very expensive, but the production goes like this, and once you need more, if you turn on the second one, it's going to go high, and then it's a straight high. And then the capacity has to be really smooth going on with it, because when you say turn on the second machine, the hydro plant, it will provide more electricity. So if you do infrequently, you will have shortage in hydros, and if you do it too frequently, it's going to be very costly for you. And the second thing is a frequency of capacity reduction. So this is the reverse thing. So when you have a temporary reduction, how quick you temporarily reduce this, or how fast, and or there is a permanent reductions. So there is, once the cost goes down, there is also a hidden cost, which is not very clear for regular people, is the cost of, releasing people, for example, or bringing more people, because everybody will have some learning curve and cost of association and all these things. So you need to find the best and the smoothest way for when it comes to the manpower, or buying, for example, in warehouse products to produce later on. And there is, in later chapters, we will talk about these things, in how you do just in time, and lean and lean system, and also you estimate the amount that you need to put them in warehousing. Because when you buy something, um, primary goods, that you need to process it, that's a cost, which is money sitting in your warehouse. And that's probably even the process times, also the money sitting in your warehouse and in the processing. So that's, it will lower the profit level. The last option that you do, probably we look at it, and it's an external source of operation and supply capacity. Sometimes you run to a higher demand that you're not expecting, or and you have no option but to outsource it. For example, you know, lots of manufacturing, for example, Dell does that. It's outsourced assembly of Dell PCs, laptop, to China, for example. So that's some of it we see of Dell produced in USA, some of them outsourced to Ireland, some of them outsourced to China. So you see the assembly probably could be somewhere else. So the outsourcing is one of the way to consider that, and also the sharing capacity. And this is happening in the hydro case, sharing capacities. I was working on a project in Winnipeg for a hydro Konawapa. It's called Konawapa, a long time ago. And basically, we knew that every time you turn on one turbine, the electricity, it really goes high, and there is an excess of electricity. So they wanted to find out how they minimize this thing through outsourcing, sharing capacity with USA. So when they, in the morning, when they turn on one more turbine, the capacity in Manitoba, one of it goes really high, and the excess goes to USA. In nighttime, there is a reverse where they shut some turbines and they buy some electricity from USA because it's cheaper too. And this is how you share the capacity in many cases. Okay. So here, when you see, is if we're looking at the volume, and if you look at the years, and probably you cannot go as smooth as the way that the demand forecasted. You need a machinery to set up who produce a little bit higher than the product. And the smaller it gets here, the more efficient. The smaller the chunk is a more efficient. The larger the chunk is less efficient. And here where you put more pressure of capacity sharing and capacity outsourcing. So it's a good example to look at these turbines who provide electricities. So if you don't do enough capacity level infrequent expansion, so what will happen to you every time in the long term you do an infrequent expansion? There's so much increase in cost. And if you keep adding small infrequent expansion, which is called a frequent expansion. And that's where you want to make sure that you're close to your cost, you're minimizing your cost. But also the work itself, type of work, is, as we said, for example, it will dictate how you work, and you need to consider these gaps. So basically, if you're working for providing electricity, it's very high anytime you turn on the turbine. But if you're producing, I don't know, water, that would probably will be, the chunk is smaller. But you need to take these into consideration, especially the accountants, the cost accounting people who's in charge of that. They usually do take care of such issues. As an operation manager or somebody on the plan supervisor, they also have to look at these issues. So when you see in the manufacturing, they need to determine the capacity requirement, and there is 3 steps on them. And then the 3 steps, the first step, what you do is you use the forecasting to predict what's the sales level. And usually salespeople will be giving you this forecasting. So use a forecasting to predict the sales for the individual product within each product line. The second step, you calculate the equipment labor requirement to meet these forecasts. And the third step, you project the labor and the equipment availabilities over the planning horizon. So you calculate and whether they are available or not. So you do the calculation and see if there is a shortage, so you can subcontract some of it to them, or you have over capacities, you can outsource this to somebody or make a decision plan whether you want to lay off some people or give them a short-term vacation or something like that. So these are 3 steps you need to take while you're working. And a good example, if we look at this example, which is called it's about the Stewart company, and you don't need to know how to do this calculation. You need to understand how this calculation is done, and because there is from here and down, there is a lot probably the softwares who can do that, but you need to know why they do that. So let's assume that there is a Stewart company who produced 2 flavors of salad dressing. One's called Paul's and the other Newman's, and each is available in a bottle and a single serving. So in bag or in a bottle. What are the equipment and labor requirement for the next 5 years? Now, so the first step you do, you need to know your capacities and the sales prediction. Now, in the line of capacity, we have a 3 machine that can package 150,000 bottles each year. And we need 2 operators for each machine, 2 manpower for each machine. And that is, we have 5 machines that can package 250,000 plastic bags each year. Here where we need 3 operators for each machine. So because we have 5 here, and we need 3 operators for each machine, means 15 people if it's at a full capacity. And we can then produce 250,000 plastic bags. In the bottle case, we need 2 people, and because we have 3 machines, so we need 6 people, and also we will end up producing 150,000 package every year. Per year. So already we know about our capacity. Now we need to know about the sales prediction. So the first step, you use the forecasting to predict the sales for individual product. And we have, for example, in the first year, for the Pulse one, in bottles, we need 60,000. And in the plastic type, we're gonna need 100,000. And the Newman's type, we need 75,000 bottles to be produced, and we need 200,000 plastic. That's in the first year. So already we have the sales predictions coming from the sales department. This is how much they need this year, the second year. So it's clear how much is demanded, and we already know about our factory, how much can produce. So the second step, we need to do the calculation of equipment and labor. So then here, total bottles that, the machines can produce total bottles, 135,000, because you got 60 plus 75, 60 plastic bottles plus 75 is 135, and the bottle ones is the bags one, plastic bags 200 and 101. So it's clear now we need first year 135,000 bottles to be produced, and we need 300,000 plastics. So the capacity here, bottling operation operate 6 of them year 1, and bagging operation operate 125,000 operators, 15 of them 1 year. Here is, once we know how many bottles and how many plastic we do, and we know how many machines and how many people need per machine, we can do this calculation. So we know now is the capacity, percentage of capacity utilized. So the machine probably can produce 90, and we do only 30 of them, which is a 30%. Percentage of capacity utilized is 30%. And machine requirement, how many machines we need? We need 0.9 or 1 machine to work. So we can divide these over the machines. And the labor-wise, we have the labor requirement 1.8, which goes to 2 people. And then in the plastic bags, percentage we are utilizing the first year is 24%, and the machine 1.2, which is we have to operate, we cannot run 1.2 machines. So you need to add 0.9 and 1.2 becomes 2.1. Still, you have to operate at least 3, and labor requirement 3.6, which is 4. Eventually, as the percentage increases, and we know in the 5 years down the road, we have to produce 77% of have the machine is operating, where we're going to need 2.3 machines operating, and the factory will be capacity of 77% in that line, and 94% for the plastic operations and machine requirement. Just look at these numbers and try to understand. It's very easy to operate on it, to understand it. Now, there is other way of looking at it, and today there is also very good applications in the market, so they can make a decision tree for capacity analysis. And it's basically a decision tree is a schematic model of sequence of steps in a problem. So it does step by step to solve the problem, including a conditions, what if analysis, and there is a condition there, and consequences for each step. Decision tree helps analyze understanding the problem and assist in identifying the best solution. So it will break down all the problems on a small chunks, and it makes it easy for you to analyze it and make a decision mathematically. Decision tree is made of these components that you need to know. One is the decision knots, which is represent the square. You know, when we make a decision, we make it look like a square. And chance of event, the choices, which is represented by circles, and branches, links between the knots, show the choices available to the decision makers. We'll see and look at it how it works. Okay, just a quick example. So when you look at the decision tree, it makes sense for you. The owner of Hacker Computer stores is evaluating 3 options. They want to expand at the current site, with their site, make it expanded. They want to make another factory somewhere else, or make another center. Or the third option, they say, well, let's not do anything. So they break down the options and they say, well, if we expand at the current, what will happen? What's the chance of this happen? What's the profit? What's the cost? And start comparing them. So the decision process include the following assumption and condition. If it's a strong growth, has a probability of 55%. The move to a new site will cost 210,000. So if they want to go to a new site, it's going to cost them 210,000. The annual return, if there is a strong growth, which is 55%, is 195 in case they move there. If there is a weak growth, is the annual sales or annual return is 115,000. Now, in case of they say we will be expanding, expanding a current and now moving, just expanding the current site would cost them only $87,000 in either year 1, or maybe they want to do expanding in year 2. Because there is one of the decision this year, let's not do anything, and next year we'll be expanding. The third decision is just we do nothing. And if there is doing the expanding, since the cost will be only 87,000, where the first one moving, having a different planet, is 210,000. The annual growth, strong growth is $190,000. And if they have a week, is 115. So right away, your mind, if you look at numbers, you will say, well, let's expand. Let's move somewhere, not expand, because we're going to make strong growth of 195. And even if it's weak, it's still more. But this is not how it looks like. Let's say we do nothing. And in do nothing, we're going to make, if there is a strong growth, we're just going to make 170,000, and the weak growth 105. So looking at these three options right now, just the growth, we see best option is making, moving another building. So the operating costs also, we're assuming everything is the same. Now, the first step we need to do is we do a calculation. And the calculation is, if it's a strong growth, it's going to be 195 and multiplied by 5 years, and our cost is 210. So we will end up making a value of 765. If it's a weak one, the cost is the same, but we're going to end up making 365 here. Now, expanding its store, if it's strong and the cost is very low, we make a 863. And if its growth is weak, 430. Now, if you look at it, here you start thinking, okay, so let's not expand. Let's not go somewhere else and just expand. In the first time when we looked at it, we decided that, well, wait a second, let's make somewhere else another plant. But now we say, no, let's expand, because in expanding, in the both case, we are making a better value here. 863 better than 765, and 413 is better than 365. Let's not make that decision yet. The third option is do nothing. Now, strong growth, and we expand next year. So the same cost, because we're just expanding, we're not moving anywhere, and the value is going to generate for us 843. Okay, if it's a straight growth. So the other option is do nothing, strong growth, do expand next year. We said that we're not going to do anything this year, and if there is a strong growth, we expand next year. And the other thing is do nothing, and if it's a weak growth, we're not going to do anything. So this situation, it makes this year we're not spending anything, and if it's a strong growth, we're just going to expand next year. And the second one, do nothing, if there is a weak growth, and because we're doing nothing, is the cost is low. It becomes more complicated, especially if you have a different options in the different countries or in different locations, and how you're going to do that. So this is why there is application will be helping you to really evaluate them step by step. So you look at the payoff, and here is you look at the backward, and the backward is like the payoffs. And as we said, these are the decisions, the squares, and what if analysis of the stage that you're going to take in a circle. In the first one, we have a revenue minus move minus cost, revenue move from move minus cost, and the chance of 55%. And you have weak growth, if it's your growth is 45%. It's the same thing applicable the percentage wise. But here, when you do nothing, then suddenly a first year, if you make a low growth, you stay with a 45%. And if you make a big growth, 55, then the decision is whether you expand or do nothing. And it seems to me that the decision comes in here and the choice is here. Now let's see why the choice at do nothing to this year. This is makes it really clear probably because first thing you look at the 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 value, the revenue, the real income from these stuff, and the real income comes in from revenue minus cost. And to do the calculation, the first one, let's look at this example, the first one. You have a strong growth, which is we said 0.55%, and weak growth 0.45%. And what do? You multiply this into 55%, and you multiply 365 into 45%, and this is the calculation. So the weight average, you look at the weight average, and there is the weight average is you add them together, and then you get 585. So the first to move is only you make 585,000, the weight average, the values. On the second one, when you do an expanding, the weight average is 660. So you remember the first time we decided to go there, and then we looked at pure numbers, and then we decided to go there. And you do the same calculation. You multiply this by 55% and this for 413 by 45%, and you add them together, you will end up 660. Now, in the choice of do nothing, in the do nothing is basically you're making 843 if you're expanding later on, which is that will multiply by 55%, and basically you will end up having you do this calculation, and in case of do nothing, you make 850, and the 850, which is this is the revenue, do nothing, and if you're expanding, you make 843. So you choose the revenue of do nothing first thing. And then, so your decision here, if you have only this part, you make a decision that I will choose this one. But it gets more complicated because your choice is first year I'm gonna do nothing, and second year I will do something. So you go backward. And here, what do you have? You have 850, which is you choose this one over this one, and you multiply it by 55%. And then you have 525 with a weak growth, and you multiply it, and you add them, you end up with a 703,000. Now, if you compare the three numbers, the value of 585 versus 660 and 703, it's clearly 703 is your best value you're going to get. And then you look back and you see that you need to do nothing, and the decision will finalize with a nothing. This is done by cost accounting, predictions, sales. There is, as we said, there is an application who can do that for you, because sometimes it gets more complicated. But you need to know how this thing is done. Now, to get it a little bit more complicated, there is a future value, or it's called discount factor. $100 today worth probably $90 to next year. So you need to take into consideration the investment that you're going to put this year, and if you're putting this money in a bank, how much is going to make you as a revenue. But on the other hand, you have a discount factor. If you're consuming this money today and you're not saving it for 5 years down the road, how much is this worth when it comes to the down the road? And this is another way of doing the calculation, where they give you the percentage which is the discount factor 1 plus the interest rate. So if the interest is 16 and you multiply it by power of the number of years there, so if you're 16, 1 plus 16 is becomes 17, and you do the multiply by how many years, and you will end up having, if you're investing the value, I mean, 195 and your cost 210, the value what you're going to generate in revenue is multiplied by 3.7, which is your value will be 418. As we said, you don't need to do the calculation part. You need to understand how these things it works. So in the decision-making procedures, there is a future value, and there is, you need to call, it's called NPV, and it's 1 plus the percentage that the bank or the market is. So we multiply by how many years there. If you want to put it into calculation, so when it gets this to the management will look at this and will get the result of saying, okay, if I'm moving, my cost, revenue minus cost, revenue of move minus cost will be 428 multiplied by 0.55, and revenue from move minus cost is in the week growth will be 166.54, because we already implementing the NAP value. And once you add these together, when you multiply this by this and this by this, you add them together, you become 310. The expanding becomes 402, which is revenue coming from expansion minus the cost, and revenue expansion minus the cost in case of weakened growth. Once again, you multiply this in 55%, you multiply this in 45%, and you end up 44. And you do the same thing, and you start this, and this becomes 665 if you do nothing. So your choice with the 665, you move on and you multiply whatever you remain to 55. And this is done by computer very quickly. The value, the final value, you look at it and you see that here you make 310,000, here 420. So if you have a choice between this and this, you will choose to expand and not to move. But if you have the choice between the three, you would choose do nothing. And because doing nothing, the value that you have is a 460 more than the others. So you cancel this, move, cancel your expand, and do nothing. So you notice the first impression that we have, oh, let's move, because we see the number is pretty high. But then we put the cost of moving versus the cost of expansion. Then we said, no, let's do the expansion. And then when we came the option of doing nothing, then we saw that the doing nothing is probably more feasible, because the value, the end value is more, and gets more clearer once you put the NPV analysis, which is the dollar today you have, how much is worth in five years down the road. It's very important that you take it into consideration also. So with this decision making, you need to work backward to come with the decision, and the decision was do nothing. Let's go with next step. Now in the next step, we have production and we have services. And manufacturing capacity differs than service capacity. In the manufacturing capacity, you have goods that can be stored for later, so you can have a warehouse. Goods that can be shipped to other locations, so if it's not working here, you can ship it somewhere else where they need a demand, so you can ship it there. And then you have the volatilities of demand relatively low. So this it doesn't shift up and down a lot like services. Now, in the service, the capacity must be available when the service is needed. So you cannot, if 5 people works in a bank, they have to provide, bank have to provide service for them. But if there is 10 people working in a bank, banks also have to increase the people who provide that service to them. So the capacity must be available service when service is needed and cannot be stored. And if there is nobody walks in and you have 10 people standing there, it's gone. Your capacity, the money you're putting in, is evaporated. The other thing, service must be available at the customer demand point. Whenever the customer wants this, the service should be available. And then later on, we talk about efficiency versus effectiveness. For example, if you walk in a store and there is 5 people and you don't wait a lot to get your service, this is a very effective service. But if you walk in a store and there is 5 people, 4 of them doing nothing, see, same scenario, then this is inefficient services. Not for you, for them, because they're putting sources and they're wasting the source. So the service must be available at the customer demand point. And also have a much higher demand volatility compared to products. The shift could be very high and low because during the lunch hour, everybody's going to do their work. So they go to the telco and they pay their bills or getting some service or getting, signing. So during that 1 hour could be very heavy. Same thing during regular days, off season and semesters. If you go to the restaurant around your college or university, there is not much there. But if you go to during your school time, you will see very busy of doing that. The restaurant is very busy. So this is the thing that you need to look at them and see the difference between services and products. Okay. Apologize, I just got a short message, so I have to answer it. Now, so the capacity utilization, by the way, we're going to talk more about these in later chapters. And we go into details of how much amount you need as a product or how much people in the service should be. But the capacity utilization and the service quality, as we said, capacity utilization this is what you call efficiency. And service quality, this is what you call effectiveness. When you go and you don't have to wait a lot in a lineup, it means the supplier, which is the mobile store or the clothing store, and you don't have to wait a lot, they service you very quickly, it means they are very effective. But if you wait a lot, they are not effective. If they have lots of people, then they are not doing a good capacity utilization. But if they have exact the number for providing the service, they're doing a very good capacity utilization. So, in other words, The relationship between service capacity utilization and service quality is critical. Utilization is measured by the portion of time servers are busy. How busy is these people who are providing the service? So there's what's their percentage of being busy. The optimal level of utilization are context specific. So basically, low rate are appropriate when the degree of uncertainty in demand is high and or the stake is high. An example is emergency room and fire department. What does that mean? Means somebody is about to die, and if there is no doctor available, he will die. So if you're running a full capacity in a hospital and somebody come in and is about to die, and because you're running full capacity and there is no doctors available for him, then you are risking a life of one person. So risking that person is very important, not to die. So you need to work below the capacity where if some emergency happens, a fire or somebody who is coming to the hospital is about to die, there should be a doctor to provide them. So you don't work at the full capacity for the employees. And these are in this, so depend on the industry, you will find out each industry works at a certain capacity. The higher rate are possible for predictable service or those without extensive customers, like community training, a postal sorting. Now, if it's the service is stable, like cleaning, like postal services, like then you probably want to run at a 90% of the individual capacity or 80 or very high. But in the hospital where there is emergencies or fire department where the emergency, you don't want them to be running at the full capacity because you need them to respond to emergencies. So if you look at this graph, is basically we have need to do two calculation, and you see them when you walk in Walmart. There is people who is clicking how many people walks in, how many people walks out, and this is one of the things that they want to calculate the capacity of the services, and even in some stores. Now there is you need to calculate the mean of arrival. How many people comes at what time? So the average arrival rate. And then you need to calculate the average, the mean service rate. How many people, for example, every 5 minutes, if I can do one service, or every half an hour, I can do one service, you need to calculate this average. And you need to balance them. At the 70 level, 70% of their level, which is you are, if number of people coming, average people coming in, is takes less time than the service provided by average people is here, then you are in the sufficient level, which is the sufficient capacity. Then if you go more than 70% of their operation, and this is in certain operation, probably in the hospital, probably lower than 70% of the doctor's times and the nurse's time. If you go more than that, and due to more people comes in or your service is more complicated, then you get into critical zone where more people coming in and more people going out because your service is taking longer. And there, when it comes at 100%, then there is no service. Here you got the service zone and everybody could be happy. Here is no services and you start complaining and you probably not staying there. You just go and say, I don't have time for this. I can go some other time or go somebody who is empty. So they need to do a mean arrivals rate, an average people who is getting the service. So at this level, A sufficient capacity provide the quality services. Once it's here, the quality goes, nah, not too quality. The service quality declines, distribution and disruption, and a high arrival level to the long wait time. So people who are waiting start complaining. The people who is providing the service, if somebody takes longer, they start getting nervous and a little bit angry. The service stays bad. And then if it's too many people, then there is no bad service at all. So it's such a calculation is need to be done in a certain hours, or could be in certain time of the year. For example, during the Christmas time is different than during the regular time. In restaurant, during the lunch hour is different than off peak. And sometimes you see these service provider, uh, they trying to, provide more discount in a certain time, so they come in here. And in the first week, I think we spoke about, we have four kind. We have the pure product, we have the product and there is a service behind it, and we have the service and the product behind it, and we have a pure service. So all these might make a big difference in even people, when can they wait, how long they can wait, and they need, operations managers need to do these calculations properly for each their location and sectors. So by end of this, we finished this chapter, and I hope I'll see you, talk to you in after the class, or next week.